Hello, I'm back again to continue with my introduction to Tabula, the Tabula programming tool. In the previous video clip, I showed you the basics of how we define states and events and how we enter into the grid here the rules for transitioning from one state to another as a function of the events that take place. And the example I used was the push-on, push-off light switch, where the first press and release of the button causes the light to come on, and then the second press of the button causes the light to come off. And you'll recall that I set the current state here, and then by holding down the shift key I can click on the events and watch the state machine transition through the various states like that. Now, so far what we have is a grid which contains the logical definition of what our state machine is to do. So far it doesn't contain any actual SPLat code. Now, while Tabula is smart, it's not able to generate automatically the code to do all these various things. So we have to put that in manually as code snippets. But it's actually quite a simple process, and the nice thing about it is you only have to think about one tiny little bit of code at a time, rather than, and you don't have to have any consideration for how it fits into the grand scheme. So let's start off by defining the events, the code for the events. Now, when I left click on one of the events, I get this window here, which is for defining the event. It has a name, which we have already filled in. Then it has two tabs, one for tooltip, which we have already filled in, and one for the code. Now, in the code window, all we have to do is enter the SPLat code, which will evaluate as a true value in the X register if the event has taken place. So in this case, we're interested in the button being on, so I'm going to put in the code with a couple of assumptions here initially, that we input, let me get that right, input the button. We assume that somewhere button has been defined, iButton has been defined as the correct input, and that's it. If the button is on, we will get a true in the X register. If the button is off, we will get a false. So that actually defines the code. Now, you'll notice two things here. First of all, the label has for button press is now hard left, whereas before the code was defined, as in this one, it's indented ever so slightly. And the other thing you'll notice is that when I go over there, instead of seeing that short form tooltip that I had before, I now actually see the code popping up. So this is a little less suitable now for a customer to look at, but I can also fix that by putting a comment into that code. So I'll go here and I'll enter a new line, and I'll put in a comment, the button is pressed. If I now go back there and look at the tooltip, we now have the comment there again, that the customer can read, and the code that we can read. Well, let me just fix up that capital H there, like that. So that's that. Now we do the same for the button release condition or event, but there's one little difference there. Here we go, input button, and we do a logical not on it. That will invert it, and that means that if the button is off, the end result in the X register is going to be a true value. So there we have it. Now, we've typed in that code just once, but it's actually going to get used in two different places. The button press is going to be used there, and it's going to be used there. It could be used in 27 different places, but we only have to type it in once. Now, for the states, what we need to type in is the code that will be executed as the state machine enters that state. So I'm going to take state number 2 initially as a relatively interesting one, and I go in and I go to the entry action cell for that state and click on that. Now what I have here is the code window. I probably should label that tab code. The entry action code for that state. And in this state we want to turn on the LED, so what I'm going to put in there is on output LED, where I assume that output LED has been defined somewhere else. I can put in a comment there if I want to. I think I've already got a comment, haven't I? And we'll look at this other stuff later. So now you can see that the entry action is there. It's a little distorted. Now that's interesting. On my other computer I'm getting a little character there to denote the tab characters. I'm not getting that here, so it might pay to just put in a space there, which will just space that out a little bit. So on output LED, and you see that again a tooltip now comes up for that cell when I've got some code in there. If there's no code in there, no code, no tooltip. Got some code, the tooltip comes on. And there's enough room in that tooltip box for 10 or so lines of code. At this stage it doesn't automatically expand or anything fancy like that. For state 3, I'm actually just waiting for a press. I don't have to do anything on entering the state because we always come to state 3 from state 2, and state 2 turns the LED on. If you want to be really fussy, you could actually, for every state in its entry action, coerce all the outputs into whatever condition you want them to be in that state. Now for the next state, the fourth state, here I need to do exactly the opposite. I need to turn the LED off. So off, I'll put that space in that I just learnt about, output LED. Okay, and now we have that there. Now we have entered our code. That's that simple. So the button press is detected by inputting the button. The button release is detected by inputting the button and doing a NOT function on it, inverting it. When we enter state 2, we turn the LED on. When we enter state 4, we turn the LED off. And that's it. That now has got enough information to produce code that will run, or something very, very close to it. So without further ado, there's one other thing that's rather important, and it's this little cell up here, and it contains a little mnemonic. Now let me click on that, and you'll see it actually is the name of the state machine itself, and without that being defined, the code generator is going to insult us fairly savagely. That little mnemonic there, and it doesn't have to be 3 letters, it could be 27 letters, but my practice is to use very short mnemonics as a brief reminder of what the function of this state machine actually is. So it might be PMP for pump, or FIL for fill, or HT for heater, or HTR for heater, or something like that. It just is an indication. Now the automatic code generation that Tabula performs uses that in all its generated line labels as a unique identifier for this section of code. And so within your whole project you must keep these things unique from one state machine to another. So we'll just leave that as it is at the moment. And now we'll go ahead and click on the code generation and see what happens. Code generate, and here you see the code that Tabula has produced for us. The first thing that we notice is that it contains some builder tags. So there is an underlying assumption with Tabula that you're going to be using builder. And the reason for that is that builder gives you a very neat tool for merging multiple files, but getting all the various parts of the individual files into the right places in the merged file, because in SPLat the position within the source file is important. You generally have some stuff that initializes tasks and then does a run tasks forever, which gets your task queue running. And then each of your modules will contain a code seg, which is the main guts of the thing, and then there is the capacity within Tabula to generate stuff that will go into NVEM and so on. So the code that we've got generated here, you actually don't have to understand it particularly, but it's fairly informative. I've got a label. You notice that the TST mnemonic appears all the time. TST launch, this is a generic label always generated, which somehow or other you are expected to do one go sub to during initialize time. Then for each state we have the TST prefix. This bit here comes from the column header for state 1, which is why the column header can't contain spaces. And then we have a label for a section of code that basically prefaces the entry, entry actions for state 1, and that's called setting the state. For state 1 there is no such code. And then we have a label which is part of a loop that is being executed continuously when the program is in that state, but it contains a yield task so that under multi-track the state is going to yield control of the processor every time around the loop. Now it's interesting to see what actually happens here. You remember that let me just move that aside a little bit. For the first state here, we were waiting for the button to come on, and the code that we put in was input the button, and there's the code there. And then here's the test that's automatically introduced by Tabula, which is if the result of this operation here was true, in other words the button was on, go to the set 2 line. So we switch to state 2. Otherwise, go back to the beginning of this loop and yield. So the code is just going to go round and round here, waiting for the button to come on, but yielding each time. In state 2, we actually have the entry action represented. Turn on the LED, yield, wait for the button, invert it, test and jump, or go back. And so here we can switch to state 3. So you can see the code logically follows the chart, of course, but Tabula has added in all this housekeeping stuff, this stuff, and this stuff, and all the labels. So it's actually saved us a fair bit of work, and it's probably even more so if you consider that one event can be used, the code for that can be used multiple times, but we've only ever had to type it in once. And of course it won't make mistakes like we might make when we're carving this code together manually. So that's the basics of entering the code. In the next clip I'll show you a little bit more about the stuff related to initialization and so on, and Builder. Thank you for listening and watching.